Hello there, this is video 3.2, solving systems of inequalities by graphing. So our concepts are, we're going to solve systems of inequality by graphing, and we're going to determine coordinates of vertices of a region formed by the graph of system of inequalities. So let's look at what our vocabulary words are. So we have system of inequality of one vocabulary word. Basically, it's just finding the ordered pairs that satisfy all the inequalities in the system. Now, because we have inequalities versus equalities, we're going to have a region, which means we're going to have more than one solution. And the only way to solve these is by graphing, because it would be impossible to list all the coordinates that overlap the region. So to solve it, the key concepts are we're going to graph each inequality, shading the correct area. We've already done graphing inequalities. But now we're going to have more than one, and we're going to find out where they overlap on the solutions. And I would suggest using matte pencils or different colored pencils to help you identify these. So let's look at example one. They want us to solve the system of inequalities. So before, the last section was system of equalities. Now we have inequalities. So how are we going to do this? Well, we're going to make a coordinate plane. Let's start with writing our system. So we have y greater than 2x minus 4, and y is less than or equal to negative, I'm going to change this to 1/2 x plus 3. Now they must be in y equals mx plus b, and then we're going to graph each one. So I'm going to graph the first one. So this means we go to the y-intercept, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So we're going to, our slope is 2, so we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Now we're going to, remember we look at our inequality sign, so it's going to be dotted. And then where do we shade? It says y is greater than, so we're going to shade all above the line, which would be on this side of the line, and we can check it by plugging in the origin 0, 0. If you forget how to solve inequalities or graph them, then we can ask me in class. So now we're going to do the next one. I'm going to change the color to, let's change it to green. So we're going to go to 3. We have a negative 1/2, so we're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. And of course, my lines are a little crooked, so bear with me. We've got a less than or equal to sign, so we know my line is going to be solid. And it says y is less than, go to the y-intercept, so we're going to color here and all below this line. But what we're concerned about, where does it overlap? It overlaps between here and here. Those are the two graphs. So it overlaps between this part of the line and this part, even though it's solid. I'm just doing this for physical reasons so you can see. So my region is here. And how would I check it? Just like before, I would pick a point in this region, and 0, 0 is clearly in this region, so I'm going to put that into both coordinates. Is 0 greater than 2 times 0 minus 4? So is 0 greater than negative 4? Yes, it is, so it works on that one. Let's check the next one. Is 0 less than or equal to 0 plus 3? 0 less than or equal to 3? Yes, it is, and I've colored the right solution to this. So pause the video, try the guided practice 1A and 1B. All right, so we're back. Let's look at example 2. So is it possible for there to be no solution? So when we had equalities, when they were parallel, that means they never cross, so they never have a solution. So, but these are different. They can be parallel and still have a solution. So here's what we had for example 1. So you notice it's broken down to 3 regions, right? Because you have the intersection of the 2 lines. Much nicer than mine. Region 1 and region 3 were solutions to this equation, y equals 2x minus 4. Region 2 and region 3 were solutions to this one. And where did they overlap? At region 3. So that is why that was the solution. So we look at example 2. And we're going to graph these two. So it's on page 147 if you want to follow along in the book. But just because they're parallel does not mean there's no solution. It depends on where the inequality sign. Y greater than or equal to x plus 5. Y less than x minus 4. Well, they have the same slope and different y-intercepts. They're linear equations, so they're parallel. So let's see what the graph looks like. Whoopsie, sorry. So we're going to go to 1, 2, 3, 4, 5, 1, 2, 3, 4. So the first one is here. We're going to go up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. So this one is going to be dotted. Since y is less than, so our region that we're shading is below, which is right here. And then we're going to come up here to 5. We're going to go up 1, over 1, up 1, over 1, up 1, over 1, down 1, over 1, down 1, over 1, and so on and so on. And it is a solid line because it's a less than or equal to. Now, this is why we've got to know stuff about equations. Well, if you look at my graph, because it's on graph paper and I didn't use a ruler, it kind of does not look like, it looks like they could be parallel, but we're not sure. We're going to shade it, it's going to be here. But what we should know, we can disregard the inequality sign and say y equals x plus 5, y equals x minus 4. That tells us, because they have the same slope, that these lines are parallel because they have different y-intercepts. And you see the solution is going this way and the solution is going this way. So they never intersect, so this is no solution or the empty set. Now, this could have been, this top one could have been less than or equal to. So at that point, it's going to go down, and then the intersection of their solutions would be right here. Or likewise, this could be greater, and the intersection could be right here at this point, or from up here and above. So it's important to look at the inequality sign and don't just assume because they're parallel that there's no solution. Stop the video, do guided practice 2A and 2B. Now we're going to look at a real-world example, which is getting us ready for linear programming. It says Chelsea has final exams in calculus, physics, and history. She has up to 25 hours to study for the exam. She plans to study for history 2 hours. She hopes to spend at least 7 hours for studying for calculus, but over 14 is too much. She hopes to spend 8 hours and 12 hours, between 8 and 12 hours on physics. Write and graph a system of inequalities to represent the situation. So the first thing we want to do is we want to identify what is, we're going to use C to represent the calculus and P to represent the physics. So you always want to identify your variables. Now we said we want to study more than at least 7 hours, so C is greater or equal to, but less than or equal to 14, because over 14 is too much. And physics, we want to do between 8 and 12 hours. Now, she's got up to 25 hours to study, but she's going to spend 2 hours for history, so we're going to subtract 2, so she's got up to 23 hours to spend on calculus and physics. So we know C plus P has to be less than or equal to 23 hours. Now, what else do we know? So if you notice, do we just have 3 equations? No, we have 5, Because remember, these are compound inequalities right here, which can be broken down to C is greater than or equal to 7, and C is less than or equal to 14, and P is greater than or equal to 8, and P is less than or equal to 12, and then we have C plus P is less than or equal to 23. And we're going to do our graph, so we don't care about the left side because we're not going to have negative hours. Okay, so these are hours, physics and calculus. And we're going to put physics over here in your independent, and we're going to put calculus as your dependent. So therefore, let's make our little marks. I don't know how many we need. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, that's a lot. Should have done it by twos, but it doesn't matter. So remember, since this is C is going to be your Y and P is going to be your X. So remember, when you have C equals, it's a horizontal line. So 1, 2, 3, 4, 5, 6, 7. Okay, and it's a straight line. And we know C is going to be greater, so we're going to shade above. And then C less than 14. 8, 9, 10, 11, 12, 13, 14. It's also going to be a horizontal line. So we're going to do less than 14 and greater than 7. So right now, they overlap right here. Now let's look at P greater than or equal. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be a vertical line. So 3, 6, 7. Okay, 3, 4, 5, 6, 7, 8. Okay, and it says, let's do a better color than this. Okay, so it says P is greater than 8. So that's going to be to the right, which right now, this is the overlapping piece of it. And then we said P is less than 12, 9, 10, 11, 12, 1, 2, 3, 4. So it's going to be here. And it's going to be the left. So again, we're just right here. Right now, the overlapping is right in this region here. Okay, then we have to graph this. So we have to solve for C. C is less than or equal to negative P plus 23. So we're going to go all the way to 23. So this is 14, 15, 16, 17, 8. So it's all the way up here, the y-intercept. So we're going to go down 1, over 1, down 1, over 1, down 1, over 1. So we kept going. It's going to go way like this somehow. So our region that's bounded is here. So we have a point here, and a point here, and a point here, and a point here, and a point here. Okay, so how many hours should she? Well, let's look. So this is 8. Isn't 10, 12 in the area? So that could be one possible. You can take any point inside this region. So she could study for 10 hours of physics and 12 hours of calculus. And that would be a good feasible region inside. So you're just getting ready for linear programming, which we'll see in the next few chapters. Okay, so let's look at the next section. I'm not going to make you do the real world problem. We can do some with our homework. If you'd like to try it, you sure may. Pause the video. So let's look up here. Now, so sometimes we might have several inequalities like we did, and it's going to form an enclosed region of a polygon. What's a polygon? Closed, flat shape with straight edges. So here, this formed a triangle, right? So we're going to have 3 vertices, and we're going to have a region in between. So the outside is called the boundary. Obviously, it forms a boundary. And then you've got the vertices where they cross. and this is going to be important for linear programming, is we need to find this vertice, this vertice, this vertice. So I have 3 different equations, but to find this vertice, I'm going to use this equation and change inequality sign to equal signs, and then I have a system of equations, and isn't where they intersect the point of solution is where they intersect, so we can solve for this. So let's look at example 4 here. It says find the coordinates of the vertices of the triangle formed by y greater than or equal to 2x minus 8, y less than negative 1/4 x plus 6, and for y greater than or equal to negative 15x minus 32. So first of all, we're going to graph them, and they graphed them for us. There's 3 equations. In order to graph them, they must be in slope-intercept form. This particular one wasn't. They had to reformat by divide. They haven't yet, but we need to divide this by 4 to solve for y. So they've graphed the 3 for us already, and we can clearly see they tell us that this coordinate is negative 4, 7, and this coordinate is 0, negative 8. How do we find this coordinate? Well, this line is y equals 2x minus 8. This line is y equals negative 1/4 x plus 6. Since we can find the intersection, change the inequality signs to equal, from the inequality to equal. So we have y equals, can't we just use substitution and substitute this in for y? So we have 2x minus 8 equals negative 1/4 x plus 6. And at this point, we're just using our properties of equations. So what did they do? They added 8 to both sides. They're going to add 1/4 x to both sides. They didn't show the step, they changed 2 to 4, or 8 over 4. And 8 over 4 plus 1 over 4 is 9 over 4 equals 14. So don't forget your fraction rules. Then we're going to multiply by the reciprocal instead of dividing by itself, which is 4 over 9, in which we have to do the same thing over here. And we get x equals 56 over 9, or if we want to change it to a mixed number, 6 and 2/9. How do we find the y coordinate? Well, we just did a section on systems. We would substitute this in for x in one of the equations and solve for y, and we get y equals 4 and 4/9. So here are our coordinates of the third vertex. It's between 6 and 7, so 6 and 2/9 is reasonable. The y coordinate of the third vertex is between 4 and 5, so 4 and 4/9 is possible. So these are our coordinates. We could see the 2 that were given. We had to find a system, use a system of equations to find the third. All right, so do guided practice 4A and 4B, and we will see you in class.